Hey guys, today's video is on solving inequalities. We've already talked a little bit about graphing inequalities on the number line, so this should be a review. Our first one, x is greater than 3. Remember, that means that our solution set can be any number greater than 3, but it does not include 3. So we use an open circle to show that 3 is not included in our solution set. In our next example, x is less than or equal to 0. That means our number can be anything less than 0, okay? But it can also be the number 0. So we shade in the circle there to show that 0 can be included in our solution set. On number 3, x is less than negative 2. That means our answer or our solution can be anything that's less than negative 2, but it does not include negative 2, so we've got an open circle there. And our last one, x is greater than or equal to negative 2. So our solution can be any number that's greater than negative 2, okay? But it can also include the number negative 2, so we use a closed circle. So just to review graphing inequalities, we use an open circle anytime that number is not included in our solution, and a closed circle when it can be or is included in our solution, when we have greater than or less than equal to, okay? So that's just a quick review, and so let's move on to actually solving some inequalities. So our first example here, we've got x plus 3 is less than 5. Our objective is still the same. We want to get the variable by itself. So in order to get x by itself, we need to subtract 3. And whatever we do on one side of the inequality, we do the same thing to the other. So 3 and negative 3 cancel each other out to have x on the left side, and it's less than 5 minus 3, which is 2. And when I go to graph that, x is less than 2, so that means open circle because it cannot include 2. And then I want to shade in everything in my graph that's less than 2. Okay. On the second example, we've got x in minus 4 is greater than or equal to negative 1. Again, we want to isolate our variable, so we've got to get rid of that minus 4 by adding 4. And whatever we do on one side of the inequality, we do the same on the other side. So our negative 4 and 4 cancel each other out. And we've got x is greater than or x is greater than or equal to 3. All right, so 3 can be included in our solution set, so we want to use a closed-in circle, and we want to shade in everything that is greater than 3. So far, same as when we're solving equations. Let's look at a couple more examples. So 5d is greater than 15, so we need to isolate the d. And I'm not sure why they have that here, but we know we need to divide both sides by 5. Okay? Those 5's cancel each other out to have d is greater than 3. Okay? And so when we graph that, 3 is not included in the solution set, but everything greater than 3 is. So that means open circle because 3 is not in our solution set. Okay? And then our next example, x divided by 4 is less than negative 1. So if we're going to divide by 4, in order to get rid of that, we've got to multiply by 4. Okay, and whatever we do on one side, we do the same to the other. And so negative 1 times 4 is negative 4. So x is less than negative 4. So that means open circle because negative 4 is not in our solution set. And we want to shade in everything that's less than negative 4. Again, looking a whole lot like when we solve equations. Okay? But there is a special situation, and that is whenever we're solving an inequality and we need to multiply or divide by a negative number. Okay? And so here we've got negative 2x is less than 4. Okay? Well, in order to solve that, we know that we need to divide both sides by negative 2. Okay? Well, since we are dividing by a negative number, our inequality sign has to reverse or flip directions. I'm not sure why this says negative 4. Okay? So the only thing that changes when we are dividing by a negative or multiplying by a negative number is this inequality sign flips direction. And we'll talk about more about why that flips and how that makes sense when you get into class. But from here, you do the same thing that you normally would. So we divided both sides by negative 2. And so x now is greater than negative 2. Okay? So the special situation with inequalities is anytime we are multiplying or dividing by a negative number. And if you want to get that in your notes, sorry about all the scribble on top, okay, but if you want to get this in your notes, when you multiply or divide an inequality by a negative number, you must reverse the direction of the inequality. So reverse or just flip the direction of that inequality. Okay, so let's look at a couple of examples and see how that works and make sure we can determine when we need to flip that inequality and when we don't. All right, so this first one, x divided by 4 is greater than or equal to negative 1. Okay, we are multiplying both sides by a positive 4. Okay, and since that's a positive 4, there's no need to reverse the inequality. So x is greater than or equal to negative 36. Okay. On our second example here, we have negative 4x is greater than 28. So in order to solve, we would need to divide both sides by negative 4. Okay. Since we are dividing by a negative number, our inequality sign has to flip or reverse the direction. So we end up with x is less than negative 7. On our third example, you've got 3x is less than or equal to negative 24. So we've got to divide both sides by 3 in order to solve the inequality. That's a positive 3, so our inequality sign does not change directions. So x is less than or equal to negative 8. Okay. If you want to, go ahead and pause here and work the next 3 on your own. All right, and I'm going to go ahead and work those out. Okay, so with the fourth example that we have here, you've got 15x is less than 20. So we need to divide both sides by 15 in order to solve that inequality. Okay, we're dividing by a positive 15, so our inequality sign does not change. And then we can just simplify that by dividing both of those by 5. So we've got x is less than 4/3. On our next example, we've got negative x divided by 5 is greater than or equal to negative 7. Okay? And to get rid of that, or to isolate our variable, we would need to multiply both sides by negative 5. Okay? And since we are multiplying by a negative 5, that means our inequality sign reverses or flips the direction. So we have x is less than or equal to 35. In your last example here, you've got negative 2x over 11 is greater than 9. And so to clear out that fraction, we want to multiply by the reciprocal. So negative 11 over 2. And we're going to do that on both sides. Okay. Since we are multiplying by a negative fraction, that means our inequality sign has to flip or reverse directions. And then we would just multiply straight across. So negative 99 over 2. Okay, so hopefully you've got a grasp now of when that inequality sign flips and when it does not. All right, we'll look at just a few more examples of solving some inequalities and graphing them. Okay, so here we've got x minus 2 is greater than 1. All we need to do is isolate the variable by adding 2 to each side. Okay. And so that means x is greater than 3. Remember, nothing flips because we did not multiply or divide by a negative number. When we graph that, x is greater than 3, so that's any number that's larger than 3. Okay? And 3 is not included in our solution set, so we've got an open circle there. Okay. Our next example, negative 4x is less than or equal to 18. Okay? So in order to isolate the variable, we've got to divide both sides by negative 4. And so since we're dividing by a negative number, our inequality sign has to flip. And so we've got negative 18 over 4 or negative 9 over 2. And to make that easier to graph, you may choose to make it a mixed number. So negative 4.5. Okay. And so what I would do is put a closed circle at negative 4.5 because it's greater than or equal to. And then I want to shade in everything that's greater than negative 4.5. Okay, if you want to, you can go ahead and pause the video and try this one on your own. Okay, and I will go ahead and work it. 4x is less than negative 12. We need to divide both sides by 4. Okay, and we're dividing by positive 4, so our inequality does not change. And we've got x is less than negative 3, where 3 is not included, so we use an open circle and shade in everything that is less than negative 3. Okay. Again, if you want to pause and try this one on your own, go ahead. I've got negative x divided by 3 is greater than 4/10. And so in order to isolate the variable, I need to multiply by negative 3. And if I do that on the left, I got to do the same thing on the right. Okay. And since we are multiplying by a negative number, our inequality sign flips. And so we've got x is less than negative 1 2/10. Okay. And so I want to put an open circle on negative 1 2/10, and we want to shade in everything that is less than that. Alright guys, I hope you have a good understanding of graphing and solving inequalities. Hey, remember, if you need to, go back through the video, take it at a slower pace, rewind, pause where you need to, and make sure that you come to class ready to graph and solve inequalities tomorrow. Have a good night, guys.